Hey everyone, welcome back, and today let's solve Leetcode problem 962 titled Maximum Width Ramp. So a ramp in an integer array nums is a pair I, j, for which I is strictly less than j, and nums at I is less than or equal to nums at j. And the width of any such ramp is j minus I. So we're given an integer array nums, and we have to return the maximum width of a ramp in nums, and if there is no ramp in nums, we want to return 0 as our default value. So in example 1, we have nums to be an input array of 6, 0, 8, 2, 1, 5, and we'd output 4 because the maximum width ramp is achieved when I and j are equal to 1 and 5 respectively, right? 1 is of course strictly less than index 5, and nums at index 1 is actually less than or equal to nums at index 5 because 0 is obviously less than or equal to 5. The values at that two corresponding indices, and in this case 5 minus 1 is 4, which is actually the maximum width ramp for any valid ramp in this input array nums. And in example 2, we have nums to be an input array of 9810194041, and we'd output 7 because that is the maximum width ramp, and it's achieved at index ij, where I and j are equal to 2 and 9 respectively. And that's because 2 is of course strictly less than 9, and nums at 2 is less than or equal to nums at 9 because 1 is obviously less than or equal to 1 itself. So I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so basically to approach this problem, we're going to use a monotonic stack to store potential starting indices of ramps. And essentially the stack is going to help us keep track of indices that might form the widest ramp. And we'll traverse through the array twice, once of course to actually build the stack, and once to actually calculate the maximum width ramp between any two indices ij using the stack and its stored values of our input array nums. So of course for our key variables and data structures used, we'll of course use a stack, basically a list used to store indices in a way that actually ensures that we can actually easily compare them later on for the widest ramp in the second iteration of our input array nums. And we'll have a max width variable which will eventually store the maximum ramp width without which we can find. So with that out of the way, let's just go ahead and dive straight into the code. So first I'm going to initialize a stack to be an empty stack, of course. That's how it's going to be initialized. And this is basically going to store indices of elements from nums, and the stack is going to help us find the widest ramp by maintaining potential starting points, basically these smaller values in nums that could form the left side of the ramp. Now let's actually loop through the indices of the range of the length of the input array nums. Again, this is going to be basically using I as our iterator to go through each index of nums if you guys are new to Python or programming in general. And the purpose here is essentially to fill the stack with different indices that may potentially be the starting point or the left end of a ramp. Okay? And now for every iteration in this for loop on line 4, we have to check if not stack. Basically, if the stack is not empty, or nums at -1, or rather nums at stack at -1 is greater, again strictly greater than nums at I. And again, this line basically checks these two conditions. First, we have to check if not stack, and sorry, I may have said it's checking if it's not empty. This actually checks if the stack is empty. Then if that case, if it's empty, then we can immediately add index I to the stack. And it also checks or if the element at nums at I is smaller than the element at the top of the stack, basically nums at stack at -1, then we can add index I to the stack. And this ensures that the stack maintains decreasing values from nums, which can potentially form the left side or starting position or index of any ramp. Okay? And if this is the case, in this conditional within every iteration of this for loop, then we know we can add to our stack or stack.append index I. And basically we'll append this current index I to the stack, which represents a potential left boundary, or again, starting position for a ramp. Okay? And after we actually exit this for loop, once we actually store all the different values and their corresponding indices in our stack, we can initialize our, I'll just call it max width, and I'm going to set it equal to 0. So this is going to keep track of the maximum width found within every iteration of our second loop of our input array nums. And again, we're going to obviously initialize this to be 0. Now let's actually traverse through the backwards or reverse of our input array nums. And in Python, it's quite easy to do this. And of course, obviously it will be in many other languages as well, like C++ or Java. We just have to say the length of the nums minus 1 as our starting position. The last index will go up until -1 exclusive, so until the 0th index, so the first element in the input array nums, inclusive, and then we'll decrement by 1 in each iteration. Just basically go 1 index to the left in each iteration. Okay? Again, this is basically a reverse for loop where j starts from the last index and moves towards the first index. And again, the goal of this loop is to find the right boundary j of any potential ramp that we encounter within this traversal of our input array nums. So now we actually have to monitor while our stack is actually non-empty and nums at the stack at -1 is less than or of course equal to the corresponding value nums at j, then we know for a fact we can simply just set I to be equal to the most recent element of the stack, or basically pop off the very last element of our stack. Okay? So again, what we do on line 10, basically inside the reverse loop, we can use this while loop to check for two different conditions. First, we check if the stack is non-empty. We're basically saying it while stack. And then we also check the element at the top of the stack, which is nums at stack at -1, if it's less than or equal to the element at the current index j, or nums at j, in this current iteration of our input array nums as we traverse backwards. And this basically means we've found a valid ramp where nums at I is less than or equal to nums at j, and we can possibly calculate its width. And we'll do that by setting I to be the stack.pop, which is going to basically be popping index I from the top of the stack, which represents the left boundary of this current iteration, or the current ramp in this traversal of our input array nums. And once we actually pop I from the stack, we have to set our max width in this iteration, I don't know, how do you spell it? I think that's how you spell width, to be equal to, of course, the maximum value, because we don't want to get it smaller, of course, itself, again, because we don't want to make it smaller, and how a ramp is defined, index j minus index I. Okay, this is basically going to be calculating the maximum width of the ramp using this max width variable as defined to be j minus I, and then we'll update the max width if and only if this new width is indeed greater than the previous max width, and we can do that pretty easily using this max function in Python. And outside of this for loop, once we have max width stored to be the maximum ramp width of any possible or valid ramp within our input array nums, for every iteration, we can eventually return max width. And so unless I made any syntax errors here, this should be accepted and this should be submitted. And as you can see, this is just about as efficient as you can get. So to basically overall explain what the code essentially does, it basically looks for a maximum width ramp in the array nums, and it first builds a stack of indices where each element represents a possible start of a ramp, basically ensuring that the elements corresponding to those indices are indeed in decreasing order. And then it then goes through the array in reverse order, checking if any elements can form a ramp with the elements stored in the stack, where basically, again, j is our right side or ending of any width or any ramp in our iteration of our nums input array. And of course, if a valid ramp is found, the width is then calculated as defined to be j minus I, the difference between the two indices, and then a maximum width variable is going to be updated based on the maximum value of those two values. So for the runtime complexity here, this is going to be a time complexity of big O of n, or a linear time solution, where n again is the length of the nums input array. And this is basically because we traverse through the list twice. It isn't necessarily a nested loop, we just traverse through it twice. So technically this is going to be big O of 2n, but when I say 2n, I basically mean big O of 2 times n, right? But that doesn't really matter because coefficients in runtime and space-time complexity aren't necessarily going to change how slow or fast a program gets, at least to a certain extent. And so we can essentially disregard coefficients in competitive programming runtime complexities like Leetcode and other sites like USACO in these cases. So this is going to simplify to big O of n, right? And of course, the reason why we traverse the list twice is to build the stack and to find the maximum with ramp. And for the space complexity, this is also going to be big O of n, because in the worst case possible, all indices could eventually be added to the stack, okay? So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.